Projectile motion.
When motion happens in 2 dimensions.
This means it has X and Y components.
There's a lot of examples of projectile motion. For example, there's golfing, there's cannonballs, there's also diving, and there's throwing. Nice catch! Basically, a projectile is any object that's thrown into space where only gravity acts on it. And projectile motion is just the motion experienced by that projectile.
In both the x and y components, there's acceleration, velocity, and displacement. Time is unique as it is independent of the components.
We can split up these components into horizontal and vertical components.
For the horizontal components, the acceleration is always 0. This means that the velocity is constant, so the initial velocity will be the same as the final velocity.
Well, for the vertical components, there's vertical velocity, both initial and final, displacement, and acceleration, which is always 9.8 meters per second. Pause. The acceleration is 9.8 due to gravity, because gravity is 9.8 meters per second. And the only acceleration vertically would be from gravity. So, there you go. Play. And remember, vertical velocity at max height is always 0.
The vertical displacement is always 0 if the object that is launched lands in a spot that is at the same height as it was launched from.
Keep in mind, time is the same for both components.
So overall, this is everything we know about projectile motion. Let's dive right into an example.
So, consider a ball. If Janelle kicks the ball at an initial velocity of 5 meters per second at an angle of 35 degrees, and the air resistance is negligible, which means that the air resistance is really small, so we don't really consider that. Then, how far is the displacement, horizontal displacement of the ball?
Alright, let's see what we have. So we know that the initial velocity that the ball was launched from is 5 meters per second. We know that the ball was launched from an angle of 35 degrees. So using these, we can draw a triangle. Know that this is 35 degrees, and that this is 5 meters per second. So using these components, we can break it down into vertical and horizontal. So we have the vertical and horizontal components. So to find the vertical component, we are going to do the opposite over the hypotenuse. So we'll need sine. So we can do 5 sine of 35 degrees is going to equal, using our calculators, 2.87 meters per second. We can also find the horizontal velocity, which is going to be 5 cos 35. And that is going to be 4.1 meters per second.
Now that we have the vertical and horizontal velocities, does anyone know what we should find first? That's right, we should find time.
How are we supposed to do that, Hannah?
We can find time using the vertical components that we were given. To find time, we can use the motion equations. So now that we have the vertical velocity, we have enough components to find time. You see we have acceleration at 9.8 meters per second down, velocity initial, which was the vertical velocity, 2.87 meters per second up, and velocity final is 0 because we're calculating from when the ball is at max height. So final velocity would be at 0 at this point. So for time, since we have to solve at the middle point, kind of, we have to multiply it by 2 at the end. So right now we're finding time at max height. So we can use the motion equation. Time equals final velocity minus initial velocity over acceleration. So we can just fill in what we have. 0 minus 7. And remember, acceleration has to be negative because it's going down, because going up is going to be the positive direction. Okay. Now we just have to plug that in and we get 0.29 seconds. Found time, and we have to multiply that by 2 because that's the final time. And then we multiply it by 2, it equals 0.59 seconds. So time is 0.59 seconds.
Yay!
Alright, so now that we have the time, we have enough components to figure out how far the object has traveled horizontally. So we can use this equation here, displacement equals the average velocity times time. And remember that for horizontal, in the horizontal direction, we can use the average velocity because there is no acceleration. So for this, we don't know this displacement. The average velocity is 4.1. Multiply it by time, which is 0.59. If we calculate this, we will get 2.42 meters. And that's all that we have to do to solve for the horizontal displacement of the ball.
Now we know how far the ball escaped before it hit the ground. That was easy peasy.
Hooray! Now try this question on your own. Consider another ball. Hannah's golfing on a cliff, which is 10 meters high, and she hits a ball at an initial velocity of 50 meters per second, off the cliff at an angle of 25 degrees. She launches the ball where it hits Janelle right on the foot. How long does it take for the ball to get from Hannah to Janelle?
All right, so now that we have somewhat of our components, let's see what we have vertically. So displacement is 10 meters down because you go from here to here. And acceleration is 9.8 meters per second squared down because gravity goes down. So then, now that we have those two components, we should find the initial velocity vertical and horizontal, if you want. So, vertical velocity should be, since we have the angle of 25 degrees going 50 meters per second, it would be 50 opposite over hypotenuse sine 25, which equals 21.13 meters per second. And horizontal would be 50 opposite over, adjacent over hypotenuse, which would be cos 25, which is equal to 45.32 meters per second. Now we have velocity initial, which is equal to 21.13 meters per second going up. Now we can use a motion equation to solve for time.
Alright, so now that we have all of these vertical components, we can use them to solve for time. We can solve for time using this equation. Displacement equals the velocity initial times time plus half of the acceleration times time squared. So if we fill this in, we'll get, I'm going to have up, the up direction is being positive, so I'm going to have negative 10 equals 21.13 time plus half negative 9.8 times time squared. And if I take the 10 over to this side to make this 0, have all the components that we need here so we can do the quadratic equation. So remember, the quadratic equation is negative b, which would be 21.13 plus or minus the square root of b squared minus 4a times c. This is all over 2a. All right, so the first thing that I'm going to do is figure out what's inside of this square root here. And get 1.545. All right, so now that we have the square root of 642.48, we can either add these or subtract them to get our answer for time. So we'll start with adding. So we have negative 21.13 plus 25.35 over negative 9.8. If we do that, we will get a negative number, which is not something that we want because time cannot be going in the negative direction. We'll get negative 0.43. So now if we subtract these instead, we should get a positive answer for time. So if we do negative 21.13 minus 25.35, that's negative 46.48. Divide that by negative 9.8, and we will get positive 4.74 seconds. And that will be our answer for time.
So, did you get 4.74 seconds? Yeah? Nice job. No, that's okay. You can try going back and double checking your steps. Anyways, thanks for watching this video, and thanks. So today we learned that projectile motion is motion that happens in 2 dimensions.
And to solve for projectile motion, we need to break down into x and y components and recombine these x and y components to solve for a final answer.
When solving for your final answer, remember that time can be helpful to solve for since it's the same in both components.
It may also be helpful to draw a diagram to help visualize the question.
Like a triangle.
Thanks for watching. Bye.
Yeah.